Okay guys, we're going to talk about 8-6 part 2 today. The good news is there's nothing new to today. You're not going to learn any new methods or any new ways of solving. We're just going to take some word problems, make sure you remember some things from Algebra 1, and go from there. You have 6 steps today. You're going to find your purpose according to the problem, draw a chart or a picture. You don't have to, but it is very beneficial. You're going to make your equations from that chart or picture. You're going to solve for your variable, check your solution, and make your therefore statement. Now, a couple of equations and charts that are going to be very helpful for you today are, you should remember that rate times time equals distance. You guys know that from science class. In fact, you probably even remember this little triangle they use in science class where distance equals rate times time. Okay, so that's where we get that from. Something else that would be beneficial for you to remember would that your rate times your time would equal the work that you do. So if like you're working for 60 minutes and you can do 20 problems in an hour, you know, you do 20 problems. The next thing that would be very important for you would be, so let's see, this would be for your distance equations. This would be for your work equations. Now another equation that we have to talk about would be an equation with like a mixture problem. And with mixture problems, I like to draw a picture. I like to do like my percent of what, like if it's saline solution or whatever kind of solution is, I do my adding and my subtracting. I put my percents on the bottom, I put my amounts on the top, and that will equal, and then you'll have a final mixture with a new percent and a total. Those will make more sense when we come to them. Those are actually some of my favorite problems. Now again, just like distance has a triangle, work would have a triangle. You could do work equals rate over time and back and forth as well. Let's jump into a few of them and see how you do. Okay, we need to decide what chart or problem we're going to use for this. Example 1. A girl lives 6 miles away from school. On her way home, she skates 4 miles before a wheel falls off her skates. Then it takes her the same amount of time to walk the rest of the way home as it did for her to skate the first 4 miles. She can skate 3 miles an hour faster than she walks. How fast can she skate? Okay, so how fast can she skate? That's my R. That's going to be my purpose, is to solve for the skates, the R for the skates. Okay, so I got my purpose. Now let's draw a chart or a picture. Since we're talking about distance and stuff, we're going to use a distance chart. Okay, so this is a distance problem, so we're going to use a distance chart. These are very helpful, especially when you come to the keystones and stuff and you have to have a distance rate times 1. Now we have 2 situations, right? We have when she walks, and we have when she's on her skates. So those are going to be our 2 labels. We know that rate times time equals the distance that she travels. So just be careful with this. All right, it says a girl lives 6 miles from school. That's the total distance, so we can kind of think up here that these 2 boxes are going to equal 6. On her way home, she skates for 4 miles. So we go to the skate column, and we go to the distance, and we put in 4 miles. Before wheels falls off her skates, so now we're going to go to walking. It then takes her the same amount of time. Now anytime you hear the same amount of time, you're going to put a T here and a T here. It takes her the same amount of time to walk the rest of the way home as it did for her to skate the first 4 miles. She can skate 3 miles an hour faster than she walks. So if her rate with walking is R, her rate with skating is 3 faster than that. R plus 3. Now we need to be able to figure out what her distance is when she walks. Now if the total distance is 6, I'm hoping you understand that this distance has to be 2. Okay, so I've gone through 2 steps. I found my purpose, I made my chart, now I make my equations. We know that R times T equals the distance. So in the walking, we have R times T equals 2. I'll use a lowercase t. When she skates, we just do R plus 3 times T equals 4. So we have our 2 equations, and our goal is to use R to get R as our answer for her skating. Since I want to solve for R, I want to isolate T by itself. So in this equation, I divide both sides by R. In this equation, I divide both sides by R plus 3. Now that I have two separate equations that both equal T, I can set my two separate equations equal to each other. This is where our section in 8-6 comes into play. You need to be able to find your common denominator of R and R plus 3 and multiply by it. Right here, you'll notice the R cancels out, and this needs an R plus 3. On this side, you'll notice the R plus 3's cancel out, and you need an R. So let's rewrite it. That would be 2 times R plus 3 equals 4 times R. Distribute in your 2, so you get 2R plus 6 equals 4R. Take over the 2R, so you get 6 equals 2R. Divide by 2, and R equals 3. Now remember, this is one of your answers, so what you need to do is go back in your chart and figure out what it is. Since we have an R in this column, that is her walking rate. So we can say she goes 3 miles an hour when she walks. But it asked about the skating rate. Well, to skate, we'll make our therefore. Therefore, she can skate at R plus 3, which equals, since R was 3, we add 3, 6 miles an hour. You can check that in your box. Everything will check out. Moving on. John can frame a poster in 25 minutes. Allison can frame the same size poster in 15 minutes. How long will it take them to frame a poster if they work together? Now what you need to understand is that some students think it's going to be between 15 minutes and 25 minutes. But if they're helping each other, even if one person is slower than the other, if they're helping each other, it's got to be smaller than 15. Because this person who works 25 is going to help her be a little more faster. This is a work problem. Two people are doing work. So we have John and we have Allison. We know that rate times time equals distance, rate times time equals work in this problem. So we need to fill things in accordingly. A lot of people think that John's rate is 25. Well, it's not. John's rate is one poster in 25 minutes. And a lot of people struggle with that. They'll just put 25 here. They think that's his rate. That's not his rate nor his time. Because we should make a note, T is time together. That's what we're trying to figure out. Capital T is time together. So we have John can do one poster in 25 minutes. Allison's going to be 1 over 15. So remember, in work problems, you have to use fractions. Their time together is the unknown, but we do know that it would be the same if they're working together. It doesn't tell us about their work, so what we're going to do is we're just going to multiply these two things together. So we'll do 1 over 25 times T. That would be 1T over 25. Do the same thing for Allison. 1 over 15 times T is T over 15. Now this is where it gets a little confusing to make your equation. Our equation depends on how many posters we want them to frame. It says how long will it take them to frame a poster. So we need their work to equal 1, because that 1 stands for one poster. So we take John's fraction of the work, T over 25, plus Allison's fraction of the work, T over 15, and we add them up. So now our goal is to get a common denominator. The common denominator between 20 and 15, 25 and 15. We'll just think of multiples of 25. You can do 25, 15 doesn't go into 25, not 50, but they both go into 75. Now when we multiply by 75, we need to figure out what's missing. This would need to be dot 3. This one would need to be 15 times dot 5. Now, think about what's 1 over. 1 is technically over 1. It's not over anything, so it needs a dot 75. And a lot of people will forget that, and they'll leave it as a 1. So I get 3t plus 5t equals 75. That's 8t equals 75. So their time together is 75 divided by 8, 9.375, and this is all in minutes. So you can see how it will always be shorter than the fastest person. So we will say, therefore, it will take, it'll take them 9.375 minutes to frame a poster. Okay, let's keep going. Problem 3. A pharmacist has 10 liters of a 9% sucrose solution, so that's going to be like a sugar solution. How much water must be added to the solution to make it a 5%? So ready? Here's what she has so far. She's got this beaker, and it is 9% pure sugar. And so far it is 10 liters. You can just put 10 on the top and know that it's in liters, so you don't have too many variables. Okay, so we know that she starts here. She's got a 9% sugar solution, and it's 10 liters. Now she wants to add some, what is she adding? She's adding water. Now you should know that water has 0% sugar in it. Okay? So she adds water. So 0%, and we don't know how much. So we put X on top of it. Now we want that to equal a new amount, but this new amount is going to be 5%. And that should make sense, because if you have something and you add water, you're diluting it. We don't know how much. We just know that it's going to be 10 plus whatever X is. So now we make our equation. We change our percents into decimals. So we'll do 0.09 times 10 plus 0 times X equals 0.05 times the quantity 10 plus X. Over here, 0.09 times 10 is 0.9. That's 0, and that equals, we distribute in, 0.05 times 10 is 0.5 plus 0.05x. Subtract 0.5 and you get 0.4 equals 0.05x. Divide and you get x equals 8. Now what we need to do is figure out what the question was. It says how much water. So we're looking for x. So this x is the amount of water. So we found our x, so we can make our therefore solution. Therefore, she should add 8 liters of water. Let's look at example 4. It took a man the same time to drive 60 miles as it took him to fly 340. The average speed of the plane is 40 faster than 5 times the speed of the car. What's the speed of the plane? This is a distance rate time chart. Why don't you go ahead, and we know we're going to have car and plane. Why don't you set it up, and we'll go talk about the solution on the next page.